Okay, so let's now start the NXOS lab. First of all, I will telnet into the system. I will actually telnet into the first pod. Here we are. So let's start with the first step, system verification, a very simple step. I will verify the hardware configuration. I will check the software version. I also will see the running config on this pod. I will try to underline the differences between the running config on an XOS respect to the running config that is present in the classical iOS. So let's see first of all what kind of hardware I have on my chassis. Again, very similar to iOS, show module. So as you can see, the engineering has done a very good job in keeping the CLI iOS look and feel so that our customers don't need to learn a new way of configuring our switch. So let's see what I have. I have a 32 ports 10 gigabit Ethernet module, and I also have a 48 ports 10100-1000 Ethernet module. They are both up and running, and this is the PID. So let's try to understand how to read the PID. Nexus N7K, of course it means Nexus 7000. M1 refers to the forwarding engine. M stands for the multipurpose forwarding engine. It actually refers to the URL. Now, if you are familiar with the 6500, on the Sub 720, we have URL version 7. On the Nexus 7000, we have the next generation of that forwarding engine, meaning URL version 8. So the number 1 that you see there stands for this is the first generation of this kind of forwarding engine on the Nexus platform. So if in the future, for example, we come up with URL version 9, you will have M2 as part of the PID on the line cards that will have that forwarding engine. The next 2 digits represent the number of ports that you have on the line card. So in this case, 32. The following letter, the letter X, indicates the speed of the ports, and in this case is 10 gigabit Ethernet, while the letter P indicates the physical interface that for this card is SFP+. The last 2 digits refer to the way that it refers to the way the line card is actually attached to the fabric modules in the back of the chassis. The first digit, the number 1, represents the series of the fabric, and in this case is the first generation of fabric modules for the Nexus 7000. The second digit, the number 2, represents the number of 40 gigabit channels that are used by the line card to attach to the fabric modules in the back of the chassis. So we have there 2. So this means that the 32 ports 10 gig card is attached to the fabric modules with 2 channels of 40 gigabit bandwidth. So it's attached with a total bandwidth of 80 gigabit per second, and we knew that. Okay, so this is the way you actually read the PID of the card. The same rules apply for the 48 ports. So we have an Nexus 7000 line card that has the URL forwarding engine has 48 ports, 1 gigabit Ethernet. T stands for RJ45, and 11 at the end of the PID means that it has the first generation of fabric, and it has only 1 channel of 40 gigabit of bandwidth that attached to the fabric modules in the back of the chassis. I have 2 supervisors, SUP1s, one is active and one is in standby. So this is what I have in the system. Let's check the fabric modules in the back. Again, show module, X bar. I have 3 fabric modules. They are all active. Again, you remember, because of the fact that I have a 32 ports 10 gig card in the system, I need 3 fabric modules in order for me to have n+1 redundancy. Okay, remember this. If I had just one 48 port line card, I would need just two to have n plus 1. Let's check the power. Show environment power. As you can see, I have 3 power supplies here. 2 are actually attached to the grid, while the third one is not. In fact, its status is shut down. I don't need 3, so 2 are more than enough. As you can see here, this is the power request by each module, each component actually. This is not the actual power that is consumed by the component. It's the maximum power in the worst possible condition. Is again like the power that is shown in the power calculator on CCO. So again, it's not the usual power. We have done some testing in the lab, and a fully loaded chassis, which with each line card forwarding line rate consumes around 6,000 watts. Of course, my system is not consuming 8,000 watts, so that is the worst case possible. Okay, as a good engineering practice, we have to reserve that amount of power. Again, it's not the power that is actually consumed by the system. Okay, so now that we have seen some hardware, let's now check the software. Again, as iOS, show version. As you can see, we are running NXOS. Actually, NXOS is composed by 2 images, the Kickstart image and the system image. The Kickstart image contains the Linux kernel. Again, NXOS runs over Linux. Okay, while the system image contains most of the software components of the NXOS. I'm running 4.0 1A, which is the first maintenance release after FCS, and the images are actually in the boot flash, as you can see, both the Kickstart and the system image. The supervisor runs over an Intel Xeon processor. It has 4 GB of RAM. The plugins that are present in my system are the core plugin and the Ethernet plugin. The core plugin contains the NXOS operating system software components, interprocess communication, PSS, and stuff like that. The Ethernet plugin contains the layer 2 and layer 3 software components. Okay. In the future, you will see also storage plugin, and it will come when we will support fiber channel over Ethernet. Okay, so let's now check the show running config, the running config. Sorry. All right, like iOS, we can see the version of the software. Again, 4.01a. As you can see here, the telnet appears in the running config. This means that the telnet is disabled by default. So the way you actually connect to the system is by using SSH. But it was easier for me to use telnet, so I enabled telnet, and now it appears in the running config. We have VRF management, which is a concept that we will analyze in the step number 2 of the NXOS lab. So for now, I will not talk about that. And those are the interfaces that belong to this VDC. So as you can see, those are not all the interfaces of the system. Those are the interfaces that have been allocated for this particular pod, and are those the only interfaces that we can configure within this VDC, meaning within this pod. Okay, and again, there is interface management, and we will talk about the interface management more in this step number 2. So as I was saying, show running config is a little bit different, meaning has more functionalities. In fact, what I can do, I can show the running config that belongs to a particular feature, as you can see. For example, show running config ERGRP, show running config IGMP, and so on. I also, something nice is to show the default values. Okay.